Good morning, children. We proceed on to miscellaneous problems of chapter 3, applications of integral calculus. Question number 1, a manufacturer's marginal revenue function is given by MR equals 275 minus X minus 0.3 X square. Find the increase in the total revenue. If the production is increased from 10 to 20, we call X to be the production. And given X changes from 10 to 20. So, X value from 10 to 20 increased. So, I need revenue. So, total revenue represents R. The formula integral MR dx. Since they have given from 10 to 20, we need to integrate from 10 till 20. What is MR given? 275 minus X minus 0.3 X square dx. As we remember integration formula, 275 is a constant, it will become into X minus X will become, no power tells me 1. So what is the formula for integral X power n dx? X power n plus 1 by n plus 1. As we apply the formula, X power 1 will become X power 1 plus 1 by 1 plus 1 or X square by 2 minus 0.3 X square will become X power 2 plus 1 by 2 plus 1, that is X cube by 3 between the limits 10 to 20. Let us remember we used to put plus C, but if limits are given for the integral, we should not put C. As I substitute R equals 275 into 20 minus 20 square by 2 minus 0.3 by 3, I can cancel, it is 0.1, 20 cube, upper limit minus, we need to put lower limit, wherever X comes put 10, it is 275 into 10 minus 10 square by 2 minus 0.1, 10 cube. As we use the calculator and simplify, it is 5500 minus 200 minus 20 cube is 8000 into 0.1, 800. This is upper limit minus lower limit 275 into 10. 2750, 10 square 100 by 250, 10 cube is 1000, 1000 into 0.1 is 100. As we simplify, it is 4500 minus 2600 or 1900. So the question is total revenue, how much it is increasing. Let us give the answer in words. Increase in the total revenue. How much the revenue increases? So, increase in the total revenue is rupees 1900. Question number 2. A company has determined that marginal cost of X product is MC equals 125 plus 10x minus x square by 9, where C is the cost of producing X units. If the fixed cost is 250 rupees, what is the cost of producing 15 units? As we know, to find cost, the formula integral MC dx. As we integrate 125 plus 10x minus x square by 9. We remember constant becomes into x. plus 10 into x becomes x square by 2 minus 1 by 9 as it is, x square becomes x power 3 by 3 plus constant. Already C comes as cost, so introduce K as the constant. Given fixed cost is rupees 250. That implies constant to be taken as 250. Whenever fixed cost is given, consider the constant as the fixed cost. So what is capital C? It is 125x plus, as I cancel, 5x square minus x cube by 9 3s are 27 plus K value 250. The question is to find C when x is equal to 15 units. So in the place of x, let us substitute 15. 125 into 15 plus 5 into 15 square minus 15 cube by 27 plus 250. Use your calculator and simplify the answer. We get C equals 3125. Take and write the answer in words. Cost of producing 15 units is rupees 3125. Question number 3. The marginal revenue function is given by MR equals 2 by x plus 3 minus 2x by x plus 3 the whole square plus 5. Show that the demand function P is 2 by x plus 3 plus 5. As we are given marginal function 2 by x plus 3 minus 2x by x plus 3 the whole square plus 5. To get revenue, we need to integrate. Before that, let us try to simplify this. These two terms, we have 2 common, also x plus 3 common. If I take 2 by x plus 3 out, this is 1 minus 2 by 1 power is taken, so x by x plus 3. X plus 3 the whole square is there. 1 x plus 3 I have taken, 1 x plus 3 remains plus 5. As we take LCM, MR is 2 by x plus 3 into, here the LCM x plus 3, as I cross multiply, x plus 3 minus x plus 5. X and x cancels. We are left with 2 into 3, that is 6. Denominator x plus 3 into x plus 3, x plus 3 the whole square plus 5. As we know, revenue equals integral MR dx. R equals integral 6 by x plus 3 the whole square plus 5 dx. We remember 6 into 1 by x plus 3 the whole square will be written as x plus 3 power minus 2. And what is the power rule? Integral x power n dx is x power n plus 1 by n plus 1. Here the power is minus 2. Minus 2 plus 1 by minus 2 plus 1 plus constant will become into x plus introduce the integration constant, that is k. As I simplify, it is 6 into x plus 3 power minus 2 plus 1 minus 1 divided by minus 2 plus 1 minus 1 plus 5x plus k. R equals minus 6 by x plus 3 power minus 1 comes to the denominator with power 1 plus 5x plus k. When x is 0, that is when the output is 0, there is no revenue, so R becomes 0. As I substitute x 0, R is also 0. Check out what is K value. 0 equals minus 6 by 0 plus 3, that is 3, plus 5 into 0, 0 plus K, or I get K value equals 2. Once I find out what is K, let me put it back here. So what is R? R equals minus 6 by x plus 3 plus 5x plus 2. My question is to find the demand function, that is small p, which is nothing but average revenue. So small p represents capital R, revenue, divide by x. Minus 6 by x plus 3 plus 5x plus 2 divide by x. Or we get minus 6 by x into x plus 3 plus 5x by x is 5 plus 2 by x. As I take LCM for these two, since I want only 5 here, 2 by x plus 3, I get 5 plus x into x plus 3. Here minus 6 plus 2 into x plus 3. As I simplify, 5 plus minus 6 plus 2x plus 6, 2x plus 6 divided by x into x plus 3. 6 and 6 gets cancelled. P equals 5 plus 2x by x into x plus 3. Cancelling x, we arrive at 5 plus 2 by x plus 3, which is the demand function to be shown. Question number 4. Given marginal revenue, find revenue function and demand function. We know revenue is integral MR dx. As we substitute, 6 constant will become 6x. Minus 3, x square becomes x cube by 3. Minus x power 3 becomes x power 4 by 4. Introduce a constant, that is k. If x is 0, output 0 tells me revenue 0. As I put 0, 0, 0, 0, k also becomes 0. So revenue is 6x minus, as I cancel 3, x cube minus x power 4 by 4. My question is to find out demand. We know demand function small p equals capital R, revenue, divide by x. Small p is 6x minus x cube minus x power 4 by 4 divide by x. As I separately divide 6x by x, x cube by x, x power 4 by 4x. We get 6 minus x square, x power 4 by x is x cube by 4. So we have calculated the demand function as well as the revenue function. Question number 5. The marginal cost is given. The marginal revenue is given. The fixed cost is given. We need to find the profit function. To get the profit function, we know it is revenue minus cost. Let us find out what is cost and revenue to get the profit. Given C dash of x is 20 plus x by 20. So what is cost function? Integral C dash of x dx. Integral 20 plus x by 20 dx. That is 20 becomes 20x plus 1 by 20 into x becomes x square by 2 plus constant. Given fixed cost is 100. So K value is 100, which is nothing but the fixed cost. As I substitute, I get capital C is 20x plus x square by 20 into 2, 40 plus K value 100. Let us proceed on to get what is revenue. Given R dash of x is 30, we need to find revenue which is integral R dash of x, or it is 30 dx. Constant will become 30 into x plus some constant, say k1. x0 tells me revenue 0. If x is 0, revenue 0, I get k1 also 0. So what is R? It is simply 30x. My question is to find the profit, and we know profit capital P is nothing but revenue minus cost. Revenue is 30x minus cost is 20x plus x square by 40 plus 100. As I subtract, capital P is 30x minus 20x minus x square by 40 minus 100. Combining these two, 30x minus 20x is 10x minus x square by 40 minus 100, and we have arrived at the answer. Question number 6. Given the demand function PD and the supply function PS, find consumer surplus and producer surplus under market equilibrium. Under market equilibrium, we know PD equals PS. 20 minus 5x is equal to 4x plus 8. As we simplify, minus 5x minus 4x equals 8 minus 20. Minus 9x equals minus 12. Or x is equal to minus 12 by minus 9, that is 4 by 3. Consider x naught equals 4 by 3. So what is P naught? I can substitute 4 by 3 either in PD or in PS. Let us take the easy one, that is 4x plus 8. 4 into 4 by 3 plus 8. As I simplify, it is 16 plus 24 by 3 or 40 divided by 3. Consumer surplus CS equals integral 0 to x naught f of x dx minus x naught p naught. Here x naught is 4 by 3. F of x is demand function, say 20 minus 5x dx minus x naught value 4 by 3, p naught value 40 by 3. As we integrate, 20 constant becomes into x minus 5x becomes x square by 2. Between the limit 0 and 4 by 3 minus 4 into 40, 160 divided by 3, 3s are 9. As we apply upper limit, 20 into 4 by 3 minus 5 by 2 into 4 by 3 the whole square. The lower limit gives me only 0 as I put 0 for x minus 160 by 9. Take LCM and simplify. CS equals, for 3 and 9, 9 is the LCM. 3 into 18, 240 minus 40 minus 160, or we get CS equals 40 by 9 units. Once we complete CS, let us proceed on to producer surplus, say PS. PS equals x naught p naught minus integral 0 to x naught g of x dx. That is nothing but x naught 4 by 3, p naught 40 by 3 minus integral 0 to 4 by 3. G of x is the supply function, say 4x plus 8 dx. Do not confuse. For consumer surplus, use the demand function. For producer surplus, use the supply function. As we integrate, it is 4 into x becomes x square by 2 plus 8 constant becoming 8x between the limit 0 to 4 by 3. It is 160 by 9 minus, putting upper limit 2 into x square 4 by 3 the whole square plus 8 into 4 by 3. The lower limit 0, as I apply, it is just giving me 0. As we simplify, it is 160 by 9 minus 16 into 2, 32 by 3 square 9 minus 8 fours are 32 by 3. Taking LCM 9, it is 160 minus 32 minus 3 times, that is 96. As we simplify, it is 32 by 9 units. Question number 7. A company requests f of x, number of hours to produce 500 units. Given f dash of x is 1800, x power minus 0.4. We need to find the number of hours required to produce additional 400 units. Initially it was 500. We need additional 400, tells me 500 plus 400, that is 900. So to calculate f of x, let us integrate 1800 x power minus 0.4 dx. So between 500 and 900, let us integrate. F of x equals 1800 x power. We remember the formula, x power n dx. The integral is x power n plus 1 by n plus 1. As I substitute, minus 0.4 is the power plus 1 divided by minus 0.4 plus 1 between the limits 500 and 900. F of x equals 1800 divided by 1 minus 0.4 is 0.6. X power 1 minus 0.4 is 0.6 between the limits 500 and 900. As we use calculator and cancel this gives rise to 3000. Upper limit 900 power 0.6 minus lower limit 500 power 0.6. These values are mentioned in the question itself. Let us just apply that. 900 power 0.6, 59.22 minus 500 power 0.6, 41.63. As we subtract, we get 17.59. As we multiply, 52770. Let us take and write the answer. Number of hours required to produce additional 400 units is 52,770 hours. Question number 8. The price elasticity of demand for a commodity is P by X cube. Find the demand function if the quantity of demand is 3 when price is rupees 2. We know price elasticity of demand is denoted by eta D. Eta D, the formula minus P by X dx by dP. But they have given P by X cube. Let us compare. Minus P by X dx by dP equals P by X cube. As I cancel P and P and X and cube, let us separate the variables. dx by dp is there. In the RHS, I have 1 by x square. Cross multiplying, we get minus x square dx equals dp. As we integrate, minus x square becomes x cube by 3. Integral dp will be just p. And whenever we integrate, remember to introduce a constant, that is k. Given the demand is 3, we call x to be the demand, that is 3. And the price we call small p, that is 2. As I substitute x cube, 3 cube by 3 equals 2 plus k, or k equals minus 27 by 3 minus 2. As I simplify, k is minus 11. Just substitute k value here. We get minus x cube by 3 equals p, k value minus 11. Bringing minus 11 to the other side, p equals minus x cube by 3 plus 11. So this we call demand function. Let us quickly glance through the problem. Elasticity of demand, we recall the formula minus p by x dx by dp. Given it is p by x cube. Cancelling p on both the sides, and x cube cancels by x square. Minus dx by dp is 1 by x square. Taking x square here and dp here. So this we call separating the variables and then integrating. Minus as it is, x square becomes x cube by 3. Integral dp just gives me p plus introduce a constant. To get the constant, we use the condition demand 3, price 2. X is 3, p is 2. As I substitute, I get k value as minus 11. Put it back in equation 1, we get minus x cube by 3 equals p minus 11. Bringing 11 to the other side, we get the required demand function. Question number 9. Find the area of the region bounded by the curve between the parabola y equals 8x square minus 4x plus 6. The y-axis and the ordinate at x is equal to 2. To find the area, we need x limits. Ordinate at x is equal to 2. Y-axis tells me x is equal to 0. Y equals 8x square and so on. The curve will be opening up like this way. We want between x is equal to 0 and x is equal to 2. So to find the area, let us integrate. Area equals integral y dx between the limits a and b. Here y-axis tells me x is equal to 0 and the other value mentioned as 2. What is y from the question? 8x square minus 4x plus 6. As I integrate, 8x square becomes x cube by 3. Recall the formula, integral x power n dx is x power n plus 1 by n plus 1. Just applying the formula, minus 4, x becomes x square by 2. 6 being constant will become 6 into x. Between the limits 0 and 2. As we simplify, putting upper limit, it is 2 cube minus 2 into x square, 2 square plus 6 into x value 2. As I put lower limit, x becomes 0, the lower limit gives me 0. As we take LCM and simplify, it is 8 by 3 into 8 minus 2 into 4 plus 6 2s are 12. LCM is 3, 64, 2 3s are 6 4s are minus 24 plus 3 12s are 36. 100 minus 24, that is 76 by 3 square units. Question number 10. Find the area of the region bounded by the curve y square equals 27x cube and the lines x is equal to 0 implies y-axis. So here the area is required to be bounded by y-axis and the limits are y is equal to 1, y is equal to 2. So what is the required area? It is integral x dy. The previous problem x limits were given, so we said y dx. Now y limits are given, so it is x dy between the y limits. Here the limits are 1 and 2. What is x from this question? Y square equals 27x cube. So what is x cube? Y square by 27. So what is x from here? Y square by 27 whole power 1 by 3. This side power 3 goes to the right as power 1 by 3. It is y power 2 by 3. Denominator 27 can be written as 3 power 3, the whole power 1 by 3. If I cancel, we get x is equal to y power 2 by 3 divided by 3. So it's a calculation that leads us to find what is x from the given equation. Y square is 27x cube, but I want only x. So keep x cube, bring 27 down. I want only x. Take 3 to the other side as power 1 by 3. Y power 2 by 3. 27 power 1 by 3. 27 can be written as 3 power 3. The whole power 1 by 3. 3 gets cancelled, giving us y power 2 by 3 by 3. Now as I substitute here, it is y power 2 by 3 dy. As we remember the integral formula, y power 2 by 3 plus 1 divided by 2 by 3 plus 1. The denominator I can very well keep out. So it is 1 by 3 into y power 2 by 3 plus 1 by 2 by 3 plus 1 between the limits 1 and 2. As we simplify, a equals 1 by 3 y power 1 plus 2 by 3. Taking LCM, 3 plus 2. It is 5 by 3. Denominator also 5 by 3 between the limits 1 and 2. Now as I reciprocate, 5 by 3 will become 3 by 5. Y power 5 by 3 alone left between the limits 1 and 2. Cancelling 3, we just get 1 by 5. Wherever y comes, put upper limit 2 power 5 by 3 minus put lower limit 1 power 5 by 3. As we simplify, it is 2 power 5 by 3 minus 1 power fraction. I just put 1 and the required area is 1 by 5 into 2 power 5 by 3 minus 1 square units.